Welcome to the DIY Honda Garage channel. DTC P0103 refers to a high voltage issue in the mass airflow MAF sensor circuit. This diagnostic trouble code indicates that the voltage signal that the engine control module, ECM, receives from the MAF sensor exceeds expected thresholds, leading to potential fueling and performance issues. The MAF sensor measures the amount of air entering the engine, which is crucial for determining the correct fuel-to-air mixture. Inaccuracy in this measurement can cause poor engine performance or increased emissions. The MAF sensor is usually located between the air filter and the throttle body. Before embarking on any troubleshooting steps, it's essential to gather all available data, including freeze-frame data and any onboard snapshots, as they may provide critical insights into the vehicle's operating conditions that triggered the code. In conclusion, DTC P0103 relates to high voltage in the MAF sensor circuit, directly impacting engine performance and emissions. Understanding the role of the MAF sensor and its crucial position within the air intake system is essential for accurate diagnostics. A systematic approach to troubleshooting can help isolate the problem effectively, from verifying electrical connections to checking the PCM and sensor functionality. Repair verification and preventive maintenance protocols should be strictly followed to ensure the longevity of repairs and prevent recurrence of similar issues. With regular checkups and attention to detail, Honda Accord owners can maintain optimal performance and reduce the likelihood of facing DTC P0103 in the future. The error described by DTC P0103 pertains specifically to the MAF sensor. The mass airflow sensor plays an integral role in assessing the amount of air entering the engine. This data is vital for the engine control module, ECM, to calculate the right fuel delivery. Typically, this sensor is situated between the air filter and the engine's intake manifold. Its wiring and connections are essential for ensuring an accurate signal is sent to the ECM. If the circuit experiences high voltage, it often indicates a malfunction, whether due to faulty component performance or electrical issues such as short circuits or poor wiring. Identifying whether the DTC is confirmed or pending is crucial, as it informs the next steps in the troubleshooting process. Several factors can trigger the DTC P0103 error code. A faulty MAF sensor is often the primary culprit, resulting in erroneous readings being transmitted to the ECM. Additionally, poor electrical connections, including loose terminals or corroded wiring at the MAF sensor or the powertrain control module, PCM, may cause increased resistance, leading to high voltage readings. The PCM itself may also exhibit internal errors, contributing to the problem. Diagnosing the root cause according to these potential issues is vital for a successful repair. Making sure to address these areas one by one can effectively isolate the problem. When DTC P0103 is active, drivers may notice several symptoms that indicate a problem. One of the most common experiences is poor engine performance, particularly during acceleration, as the incorrect air-fuel mixture leads to suboptimal combustion. Increased emissions may also be evident, as incorrect readings from the MAF sensor can lead to the engine running rich, which produces higher emissions. Rough idling can occur as the engine struggles to maintain a steady operation due to inconsistent air measuring. Additionally, the vehicle might exhibit other behaviors, such as stalling or erratic acceleration, pointing towards the necessity for a thorough diagnostic assessment. Step 1 focuses on verifying the condition of the MAF sensor circuit. Begin by turning the ignition switch to the on position, allowing the vehicle systems to initialize. Wait a minimum of 2 seconds before proceeding to check the MAF sensor parameters using the Honda Diagnostic System, HDS. Pay particular attention to the voltage readings to ensure they are under the threshold of 4.89 volts. If your readings show a value exceeding that threshold, the next step is to confirm that the failure has been replicated. In cases where the thresholds are not met but no failure is confirmed, it may indicate an intermittent issue, suggesting a need to check connections and terminals for possible damage or corrosion. In Step 2, the focus shifts to ensuring the integrity of the wiring in the variable geometry motor (VGM) line. Begin this step by turning the ignition switch to the off position. The next action is to utilize the HDS to jump the SCS line, which allows for the necessary continuity checks to proceed. After establishing this, disconnect the MAF IAT sensor connector along with the PCM connector B. Your task now is to test for continuity between specified points. The MAF IAT sensor connector number 2 and the PCM connector B number 33. If continuity exists, this indicates that the wiring is intact. Should there be a lack of continuity, it signals an open circuit, necessitating further investigation and potential repair of the associated wiring. Step 3 aims to assess the functionality of the PCM's internal circuit. Start by reconnecting the PCM connector B previously disconnected. Then, connect terminals A and B of the MAF IAT sensor with a jumper wire, facilitating an internal circuit check. With connection secure, turn the ignition switch back to the on position and use the HDS to clear any existing DTCs. Following this, verify the presence of pending or confirmed DTCs through the HDS. If DTC P0103 reappears, it indicates a potential need for a software update to the PCM or substitution with a known good PCM. If the DTC is absent, it suggests the PCM functionality is intact, thus pointing towards a defective MAF sensor or IAT sensor needing replacement. Final repair verification is crucial for confirming the effectiveness of the repairs made. Start this step by turning the ignition switch to the off position. Once the vehicle is off, ensure to reconnect all connectors that were previously disconnected, including those for the MAF sensor and PCM. Utilize the HDS to exit the SCS mode and perform a reset of the PCM. This step guarantees that any previous settings or errors from the past operation are cleared. After completing this process, turn the ignition back to the on position and carry out the idle learn procedure as specified in the service manual. Finally, check for any pending or confirmed DTCs once again to ensure that DTC P0103 does not resurface, which would indicate a continued issue that needs to be addressed. Preventive maintenance is vital in avoiding recurrence of DTC P0103. Regular inspections of the MAF sensor are advisable, focusing on both mechanical integrity and cleanliness. Dirt or debris can impair its performance significantly, leading to erroneous voltage readings. Furthermore, routinely check all electrical connections related to the MAF sensor and PCM. This includes inspecting for loose terminals, corrosion, or signs of wear that could compromise the circuit. Making sure connections are clean and secure can prevent many of the issues encountered in MAF sensor circuits. Finally, adhering to regular vehicle service intervals as per manufacturer recommendations will contribute to overall vehicle reliability. Please like and subscribe to the channel. See you next time.